Okay, so today we want to look at the double angle formulas, and what we're going to try to find here would be we're going to try to find a rule for the sine of 2x, the cosine of 2x, and for the tangent of 2x. There's going to be a few versions of this cosine, so I left some space there. Now with these are all a direct effect of, or directly from your addition formulas that we've already talked about. Okay, so with this, we'll kind of leave that as a, we can list them over there. But if we start with the sine of 2x, what you want to realize here is that 2x is the same as saying x plus x. Right? That's what 2x means. It's just repeated addition. So we know a formula for the sine of u plus v, or for the or for the sine of s plus t, however you want to look at it. And that formula, just to recall, is if you have the sine of u plus v is the sine of u cosine v plus cosine u sine v. In calc, you use u and v a bunch. So the sooner you learn to really make them look different when you write them, it's going to save you some headache later on, because they're really common. There's something called u substitution, and when we do different rules, we use u's and v's. So what I'll do here, well, u and v are both x's. So when I write this out, I get the sine of x times the cosine of x plus the cosine of x times the sine of x, which they look different because they're in opposite orders, but we know that multiplication is commutative. You could just switch them. It's the same term twice. So it's just going to be 2 times the sine of x times the cosine of x. So that's where that formula comes from. So here is 2 sine x cosine x. It's called the double angle formula, right? So if you know that, the sine of x is 1/4, you could use that to find the sine of 2x. But that's the rule you have to do. You're not allowed to just double the answer. That wouldn't work. It's not true. Okay, so when we go to find cosine, we're going to do the same thing. So for the, and if you recall here, the cosine of u plus v is cosine u cosine v minus sine u sine v. Again, that's on your formula sheet there. So when we want to find the cosine of 2x, we just do the cosine of x plus x. So now, I'm not making you memorize these. It is nice to know where they come from, though, right? To know they exist. If you look at where they come from, that might be helpful. So what we'll do is everywhere there's a u or a v, we're going to replace it with x. So we end up with the cosine of x times the cosine of x minus the sine of x times the sine of x, which gives us cosine squared x minus sine squared x. That's the first way that we can express the cosine of 2x. So cosine squared x minus sine squared x. Now, you'll notice if you look at your formula sheet, there's 3 versions here. For our purposes right now, you can always get away using this one, but sometimes you only might know the cosine function, or you only might know the sine function, or later on, if you're going to derive the half angle and double angle, or half angle and power reducing formulas, you'll need to use these other 2 versions. All those is we're just going to take this rule and we're just going to use our Pythagorean identity. Right? So the first thing we could do here is, if you take this, if you replace, so let's write cosine squared x, and let's replace sine squared x with 1 minus cosine squared x. Okay, when we do that, distribute the negative, cosine squared x minus 1 plus cosine squared x, and we get 2 cosine squared x minus 1. That's the other version, second one. And then, looks a little cosine squared x minus 1. And then to find the third version, we're just going to replace the cosine squared with 1 minus sine squared. Again, it's that fundamental Pythagorean identity that I've been yammering about all year. So 1 minus sine squared x minus sine squared x is 1 minus 2 sine squared x. They're all equivalent every time. If you use whichever one of the three you use, you will always get the same answer. Right? It's just maybe you only know cosine, so you choose to use this one, or you only know sine, or maybe you prefer that one. I always think this looks a lot like sine squared plus cosine squared, which is equal to 1. So this one's easier for me to remember. It's the one I tend to remember. So any questions so far with that? Okay, so that's how we derive those. Now to derive the tangent, maybe we'll get rid of this one here. A rule that we've used at times is that the tangent, we used this on the last video, of u plus v is tangent u plus tangent v over 1 minus tangent u tangent v. So we're going to do the same process here. We're going to let u and v both become x. So to find the tangent of x plus x, that gives us the tangent of x plus the tangent of x over 1 minus the tangent of x times the tangent of x. So we usually write that as 2 tangent x over 1 minus tangent squared x. So then from here, that is 2 tangent x over 1 minus tangent squared x. So it would be the other one. Do be aware, if you're ever given maybe some information about an angle x and you have the right triangle, if it would ever ask you to do all three of them, well, as soon as I knew the sine of 2x and the cosine of 2x, I would just do the ratio to get the tangent of 2x. I wouldn't bother using that formula. Does that follow for everybody? You could just do that ratio. It's going to be a lot quicker. Okay. So that's where those double angle formulas come from.